The story of the dinosaurs begins long before they became the giants and rulers we so often picture in our minds. To truly understand what Earth was like when dinosaurs first appeared, we must journey back over 200 million years to a time when the world was vastly different from the one we know today. This was the Triassic period, a span of time stretching from about 252 million years ago to 201 million years ago. The Triassic is the first chapter of the Mesozoic era, an era sometimes called the Age of Reptiles. But before dinosaurs became the icons of this age, the world had to recover from one of the most catastrophic events in Earth's history. At the very beginning of the Triassic, Earth was reeling from the end Permian mass extinction, also known as the Great Dying. It was the most severe extinction event in our planet's history, wiping out around 90% of marine species and about 70% of land-dwelling vertebrate species. Entire ecosystems collapsed. Coral reefs vanished, forests withered, and many animal groups disappeared forever. Volcanic activity in what is now Siberia released massive amounts of carbon dioxide and other gases into the atmosphere. This triggered runaway greenhouse warming, ocean acidification, and widespread anoxia, areas of the sea with no oxygen. The planet was left a desolate, scorched place, with shattered ecosystems slowly piecing themselves back together. When life did return, it was reshaped. This emptying of ecological niches gave a unique opportunity for survivors and newcomers to thrive. Among these survivors were the distant ancestors of the dinosaurs. During the Triassic, Earth's land masses were still joined together in one vast supercontinent called Pangaea. This colossal landmass stretched almost from pole to pole, shaped like a giant letter C. Its size meant that much of the interior of the continent was far from the sea, giving rise to harsh deserts and arid climates in its interior regions. The global climate of the Triassic was extreme. Summers in the continental interior were hot and dry, with temperatures soaring, while coastal regions experienced seasonal rains. Monsoons swept across some areas, while others remained parched deserts. There were no polar ice caps, and the poles themselves were warm compared to today, though still cooler than the equator. Vast conifer forests covered parts of the land, joined by cycads and ginkgos, while ferns and horsetails thrived in wetter areas. Though flowering plants had not yet evolved, these ancient plant groups created the foundation of the Triassic ecosystems, providing shelter and food for the creatures that would one day roam there. The Triassic is often remembered as the dawn of the dinosaurs, but in truth, it was a time when many kinds of reptiles competed for dominance. The reptile lineage had already been diversifying for tens of millions of years, splitting into two great branches: synapsids, sometimes called mammal-like reptiles, though they were not true reptiles at all. This group included the ancestors of mammals. Before the Great Dying, synapsids like Dimetrodon and Lystrosaurus were dominant land animals. After the extinction, some synapsids lingered, but their role as rulers was fading. Diapsids, the other great branch, included lizards, snakes, crocodiles, pterosaurs, marine reptiles, and the group that would eventually give rise to dinosaurs and birds. In the early Triassic, synapsids still held on, but as the period advanced, the diapsids began to dominate. Among the diapsids, two important lineages emerged: the crocodile-line archosaurs, pseudosuchians, which would eventually include the ancestors of crocodiles and alligators. During the Triassic, this group was diverse and powerful, including armored land-stalking predators. The bird-line archosaurs, ornithodyrans, which would eventually include pterosaurs, dinosaurs, and their descendants. This group started small, but within it were the seeds of what would become the most famous animals in Earth's history. The earliest creatures we would recognize as true dinosaurs appeared around 230 million years ago, during the late Triassic. They were not the towering giants of later times, but small, lightly built animals. One of the earliest known dinosaurs is Eoraptor, discovered in Argentina. Eoraptor was only about 1 meter long, lightly built, and likely an agile hunter of insects, small reptiles, and other tiny prey. It walked on 2 legs, with grasping hands and sharp teeth. Another early dinosaur was Herrerasaurus, also from South America. Herrerasaurus was larger, up to 5 to 6 meters long, and one of the earliest known large predatory dinosaurs. With its long tail and powerful legs, it was built for speed and agility. Meanwhile, plant-eating dinosaurs were also beginning to appear. Plateosaurus, for example, was an early relative of the great sauropods. It could grow up to 10 meters long, with a long neck for feeding on vegetation. These early dinosaurs were part of a broader evolutionary experiment. They lived alongside many other reptilian groups, not yet dominant, but steadily gaining an edge. It is important to remember that during the Triassic, dinosaurs were not yet the rulers of Earth. They shared the land with other archosaurs that were, in many cases, larger and more formidable. One major group was the Rauisuchians, fearsome crocodile-line predators that stalked the Triassic landscapes. Some Rauisuchians grew up to 7 meters long, with massive jaws and upright stances. They were apex predators in many environments, often overshadowing early theropod dinosaurs. There were also phytosaurs, crocodile-like reptiles with long snouts filled with teeth. Though they looked very much like crocodiles, phytosaurs were only distant relatives. They lurked in rivers and lakes, ambushing prey. Other reptiles, such as pterosaurs, were heavily armored, plant-eating creatures with spiked bodies, somewhat resembling giant armored lizards or tanks. They were not dinosaurs, but they filled important herbivorous roles in ecosystems. For much of the Triassic, these non-dinosaurian reptiles were more common and more ecologically significant than dinosaurs. Dinosaurs remained relatively small and specialized, waiting for their chance to rise. That chance came in a dramatic and devastating way. Around 201 million years ago, near the close of the Triassic, Earth experienced yet another mass extinction. This event, called the End Triassic extinction, wiped out many of the dinosaurs' most powerful rivals. The cause was likely massive volcanic eruptions as Pangaea began to break apart. These eruptions released huge amounts of carbon dioxide and other greenhouse gases, triggering rapid global warming. Ocean acidification and changes in climate devastated ecosystems. Many groups perished, including most of the Rauisuchians, pterosaurs, and other dominant reptilian lineages. But the dinosaurs survived. Their lighter, more adaptable builds and diverse diets may have helped them weather the crisis. When the dust settled, the ecological stage was clear. The powerful rivals that once overshadowed the dinosaurs were gone, and the path was open. The Jurassic period was beginning, and with it, the rise of dinosaurs to global dominance. The Triassic, then, was a period of rebuilding, experimentation, and transition. Earth moved from the ruins of the Great Dying into new forms of life. Dinosaurs were born into a world of extremes, scorching deserts, torrential monsoons, and powerful reptilian competitors. At first, they were small and unremarkable, just one of many groups of reptiles struggling for survival. But by the end of the Triassic, fate had shifted in their favor. A new extinction had cleared the field, and the adaptable, fast, and versatile dinosaurs were ready to take advantage. The dawn of the dinosaurs had arrived, setting the stage for an era that would last over 150 million years, filling Earth with giants, predators, and ecosystems of unmatched richness. The next chapter of the story would unfold in the Jurassic period, when the dinosaurs would truly begin to dominate the land, the skies, and even influence the very shape of Earth's ecosystems. The Triassic was not only the dawn of the dinosaurs, but also a time of remarkable ecological experiments. Life was rebuilding itself after the devastation of the end Permian extinction, and in this rebuilding, new forms emerged, ecosystems evolved, and the stage was set for the age of dinosaurs. Though dinosaurs had begun to appear in the late Triassic, they were far from dominant. Instead, the Triassic world was a patchwork of diverse plants, reptiles, amphibians, and mammal-like creatures, each adapting to the challenging climate and landscapes of Pangaea. To understand the world dinosaurs inherited, we must explore these ancient ecosystems in detail. The foundation of every ecosystem is its plants, and in the Triassic, the flora was strikingly different from today. Flowering plants, what we call angiosperms, had not yet evolved. Instead, the landscapes were dominated by more ancient groups. Conifers were the towering trees of the Triassic. Related to modern pines and cedars, They form dense forests in wetter regions and scattered groves in drier climates. Their needle-like leaves were well adapted to conserving water. Cycads, sometimes called living fossils, flourished across Pangaea. These plants resembled palms, but were unrelated. Their thick trunks and crown of leaves made them common sights in Triassic landscapes, especially in semi-arid environments. Ginkgos, another group that survives to this day, were present as small trees with fan-shaped leaves. They were hardy and could tolerate varied climates. Ferns and horsetails thrived in wetter areas, such as river valleys and lake shores, forming lush ground cover where larger trees could not dominate. These plants were not only food sources, but also creators of habitats. Dense conifer forests sheltered reptiles and early dinosaurs. Open plains with cycads supported herds of herbivores. Fern-rich wetlands provided breeding grounds for amphibians. The spread of these plant groups also influenced Earth's atmosphere. By photosynthesizing, they slowly increased oxygen levels after the great crashes of the Permian, setting the stage for larger, more active animals. Before reptiles came to dominate, amphibians were once the rulers of Earth's freshwater ecosystems. In the Triassic, giant amphibians, some over 4 meters long, still lived in rivers and lakes. Creatures like Metophosaurus, with its wide, flat head and sprawling limbs, resembled monstrous salamanders. These amphibians were ambush predators, waiting in the shallows for fish or small reptiles to pass by. But though they clung on, their time was fading. Reptiles, with their tougher eggs and greater ability to survive in dry conditions, were outcompeting amphibians. By the end of the Triassic, most giant amphibians had vanished, leaving only the ancestors of today's frogs, toads, and salamanders behind. During the Triassic, another group walked the land. The synapsids, often called mammal-like reptiles, though they were not true reptiles at all. These creatures were the ancestors of mammals. Early in the Triassic, synapsids were still common. Lystrosaurus, a squat, tusked herbivore, was one of the great survivors of the Permian extinction and briefly became one of the most common animals on Earth. But as the Triassic advanced, synapsids declined in diversity and importance. Yet they were evolving. Some, like the small insect-eating Cynognathus, had more advanced jaws and teeth, more mammal-like skulls, and possibly even fur. Others developed whisker-like sensory abilities, helping them hunt in the dark. These were not yet mammals, but they were on their way. By the end of the Triassic, true early mammals had appeared, tiny, shrew-like creatures that lived in the shadows of the dominant reptiles. They survived by being small, nocturnal, and adaptable, waiting for their time to come. The most important creatures of the Triassic ecosystems were the archosaurs, the ruling reptiles. This diverse group split into 2 great branches: crocodile-line archosaurs, pseudosuchians, bird-line archosaurs, which included dinosaurs and pterosaurs. Together, they reshaped the land, water, and skies. The crocodile line, archosaurs. In the Triassic, the crocodile line was incredibly diverse. They produced creatures that looked nothing like modern crocodiles. Rauisuchians were giant, upright predators with deep skulls and sharp teeth. Some grew longer than a car. They were apex hunters, stalking the forests and plains. Pterosaurs looked almost identical to crocodiles, with long, tooth-filled snouts. But unlike modern crocs, their nostrils were near their eyes, not the tips of their snouts. They lurked in rivers and lakes, ambushing prey that strayed too close. Pterosaurs were heavily armored, plant-eating reptiles. Their backs were covered in rows of bony plates, and some species had spiked armor, making them look like living tanks. They dug in the soil for roots and plants, much like wild boars. This explosion of crocodile-line forms meant that for much of the Triassic, dinosaurs were in the shadow of these powerful relatives. The bird-line archosaurs. While their cousins dominated, the bird-line archosaurs were quietly experimenting. From this branch came two crucial groups: pterosaurs, the first vertebrates to achieve powered flight. By the late Triassic, they soared over lakes and coastlines, hunting fish and insects. Dinosaurs, which began small but adaptable. Agile runners like Eoraptor and Herrerasaurus filled niches as hunters. Plant-eating dinosaurs like Plateosaurus began experimenting with larger body sizes. Though minor players at first, dinosaurs' anatomy, upright legs, efficient lungs, and lighter builds gave them long-term advantages. The ecosystems of the Triassic were complex, even if they looked very different from today's. In rivers, phytosaurs and amphibians hunted fish, while pterosaurs rooted along the banks. In forests, cynodont synapsids hunted insects at night, while Rauisuchians stalked larger prey by day. On open plains, early herbivorous dinosaurs mingled with aedosaurs, while predators like Herrerasaurus waited for opportunities. Overhead, pterosaurs glided on warm thermals, scouting the land below. Every environment, river, forest, desert, plain, was filled with this mixture of survivors and pioneers. It was a world both ancient and new, transitional and experimental. For all their diversity, many of these Triassic creatures would not survive. Around 201 million years ago, Earth entered another age of chaos. The end Triassic mass extinction, as Pangaea began to split apart. Massive volcanic eruptions created the Central Atlantic Magmatic Province, one of the largest volcanic events in Earth's history. Lava flowed for thousands of kilometers, while carbon dioxide and other gases poured into the atmosphere. The results were catastrophic. Global warming spiked temperatures. Oceans acidified, threatening marine life. Widespread extinctions struck reptiles, amphibians, and plants. The crocodile-line archosaurs, once dominant, were hit hard. Rauisuchians disappeared. Phytosaurs vanished. Aetosaurs dwindled. Amphibians collapsed further. But the dinosaurs survived. Small, adaptable, and versatile, they weathered the storm better than their rivals. When the extinction cleared, the world's ecosystems were empty of the great predators and armored herbivores that once overshadowed them. Dinosaurs stepped into the gap. As the Jurassic period began, dinosaurs were no longer just minor players in the ecosystem. They were ready to expand into every role: giant plant eaters, swift predators, long-necked browsers, and more. The Triassic was a world of transition. It began with the ruins of the Permian extinction, saw an explosion of reptilian diversity, and ended with another great extinction that cleared the way for dinosaurs. The Triassic ecosystems were extraordinary. Deserts filled with armored reptiles, rivers haunted by crocodile-like hunters, forests alive with mammal-like insect catchers, and skies just beginning to be claimed by flying reptiles. This was the world that shaped the first dinosaurs, a harsh, competitive stage that tested their abilities and forced them to evolve. Those that survived carried forward the traits that would one day let them dominate Earth for over 150 million years. In the next chapter, we move into the Jurassic period, where dinosaurs would take their first steps toward true dominance, growing larger, more diverse, and reshaping the world in their image. The Earth has changed. The fiery upheaval of the end Triassic extinction has passed, sweeping away many of the older reptilian dynasties that once competed with the dinosaurs. Now, as the early Jurassic dawns, the survivors of that turmoil are stepping into a world full of opportunity. For the dinosaurs, this is their chance to expand, diversify, and secure their place as the rulers of the land. The Earth itself is no longer the same landscape it was during the Triassic. The supercontinent Pangaea, once a single massive landmass, is beginning to fragment. Fault lines stretch, seas creep into rift valleys, and the first hints of the Atlantic Ocean are opening between what will one day become Africa and North America. These continental shifts are not rapid on a human scale, but over millions of years, they transform the world dramatically. Vast deserts that once sprawled across the center of Pangaea are shrinking and wetter. More temperate climates are spreading. With them comes lush vegetation, thick stands of conifers, ginkgos, and cycads that will become food and shelter for the rising giants. Imagine walking into a forest of the early Jurassic. Towering conifers stretch toward the sky, their needles glistening with morning dew. Giant horsetails line riverbanks, and broad-leaved cycads provide dense, palm-like foliage. Ferns sprawl across the forest floor, creating a living carpet underfoot. In these humid green landscapes, the ground trembles under the steps of some of the largest creatures ever to walk the earth. Here, The sauropods, the long-necked, long-tailed giants, are making their mark. These are the first truly massive dinosaurs. They have evolved from smaller, more lightly built ancestors in the late Triassic, but now in the early Jurassic, they begin to achieve sizes that push the boundaries of what land animals can be. One of the most iconic of these early giants is Volcanodon, an early sauropod discovered in southern Africa. Though modest in size compared to later titans, Volcanodon already shows the key features of the group. Column-like legs to support immense weight, a long neck for reaching high vegetation, and a body designed for bulk feeding. Other sauropods, like Shunnosaurus in China and Barapasaurus in India, also stride through this world, browsing from the tops of trees and clearing entire groves as they move in herds. But alongside the giants, smaller dinosaurs also flourish. Early ornithischians, plant eaters with beaks for cropping low vegetation, dart through underbrush. Among them is Scutellosaurus, a small, lightly armored dinosaur whose rows of bony plates hint at the armored stegosaurs that will later rise in the Jurassic. Agile, cautious, and covered in a primitive defense, Scutellosaurus represents the innovation and variety that define this new age. Of course, no world of herbivores exists without predators. The early Jurassic sees the rise of formidable theropods, the meat-eating dinosaurs. With the older Triassic predators gone, the stage is clear for theropods to evolve into the apex hunters of the new ecosystems. In North America, a powerful predator named Dilophosaurus prowls the forests and river valleys. Recognizable by the distinctive twin crests that run along the top of its skull, Dilophosaurus is among the largest predators of the early Jurassic, reaching over 6 meters in length. Sleek, fast, and equipped with sharp teeth and claws, it likely hunted a variety of prey, from smaller dinosaurs to early sauropods. Dilophosaurus is not alone. Across Gondwana, other early theropods emerge. In Africa, Dracovenator and Sinosaurus in China demonstrate the spread of medium to large carnivores across the continents. These predators are not yet the colossal hunters of the late Jurassic, like Allosaurus, but they are powerful and adaptable, filling niches left empty by extinction. Theropods in the early Jurassic are also experimenting with form and strategy. Some are lightly built, pursuing smaller, faster prey. Others are heavier and stronger, adapted for ambush or for taking down larger herbivores. Over time, this evolutionary experimentation will produce the diversity that defines theropods throughout the Mesozoic. One of the defining features of the Jurassic world is the emergence of herds. Evidence from fossil trackways, long sequences of footprints preserved in mud and later hardened into stone, shows that sauropods did not walk the earth alone. They moved in groups, often in lines that suggest coordinated travel. These herds may have provided protection against predators, allowing smaller or younger members to remain in the middle while large adults flanked the edges. The social lives of sauropods are hinted at in these traces. Entire herds seem to migrate together, crossing river valleys and moving towards seasonal feeding grounds. In doing so, they shape the landscape itself, trampling vegetation, dispersing seeds, and creating open paths through dense forests. Much like elephants in modern ecosystems, these massive herbivores are ecosystem engineers, transforming the environment simply by living within it. Other dinosaurs, too, may have lived in groups. Ornithischians like Scutellosaurus likely formed small herds for safety, while predators may have hunted cooperatively in some cases. Though direct evidence is limited, the rise of social behavior adds another layer of complexity to these ancient ecosystems. While dinosaurs dominated the land, the seas of the early Jurassic hosted their own giants. Marine reptiles, such as ichthyosaurs, sleek, dolphin-like predators, patrolled the oceans, hunting fish and squid. Among them, Stenopterygius is one of the most famous, with a streamlined body and evidence of live birth preserved in fossils. Some specimens capture the moment of birth itself, with tiny ichthyosaur embryos preserved within their mother's body. Plesiosaurs also emerged in the early Jurassic, with long necks and paddle-like flippers that allowed them to glide through the water with grace. Creatures like Plesiosaurus itself swam in shallow seas, hunting fish and cephalopods with needle-sharp teeth. With their unusual proportions, tiny heads at the ends of impossibly long necks, plesiosaurs would become some of the most iconic marine reptiles of the age. Ammonites, spiral-shelled relatives of squid and octopus, thrived in these seas as well. Their coiled shells litter Jurassic marine rocks, serving as markers for geologists studying this time. Ammonites were crucial to the food web, feeding on plankton and small prey, while in turn becoming prey for larger marine reptiles. The early Jurassic climate was warmer and wetter than the Triassic, thanks to rising sea levels and the breakup of Pangaea. Seasonal extremes were less harsh, and vast stretches of land once dominated by deserts were replaced with forests and floodplains. This change in climate supported the growth of enormous plant-eating dinosaurs. The breakup of Pangaea also led to the isolation of populations. As continents drifted apart, dinosaur lineages began to diversify in different directions. This geographic separation allowed evolution to proceed along unique paths, laying the groundwork for the incredible variety of dinosaurs that would characterize the later Jurassic and Cretaceous. By the close of the early Jurassic, the dinosaurs had firmly established themselves as the dominant land animals. Sauropods had begun their journey toward gigantism. Theropods had secured their role as apex predators, and smaller plant eaters were diversifying into new forms. The ecosystems were becoming more complex, more layered, and more dynamic. The stage was now set for the Middle and Late Jurassic, the true age of giants. Here, dinosaurs would reach their greatest diversity yet, with immense sauropods like Brachiosaurus and Diplodocus, and predators like Allosaurus and Ceratosaurus shaping the landscapes. The early Jurassic was a time of recovery, innovation, and expansion. The extinction that ended the Triassic had cleared the board, and the dinosaurs had taken their chance to rewrite the rules of life on land. From small, humble beginnings, they had risen into giants, and their reign was only just beginning. The Jurassic world is alive with giants. On land, herds of sauropods graze across vast plains, towering over conifer forests. Predatory theropods stalk these herds, their sharp eyes watching for weakness in the ranks. But if you lift your gaze upward, you'll see that the skies, too, are filled with motion. For the first time in Earth's history, vertebrates truly dominate the air, and their wings belong not to birds, but to the pterosaurs. And beyond the forests, where rivers spill into shallow seas, another realm of giants thrives. The oceans of the Jurassic are full of predators and prey, from ammonites drifting in the currents to immense marine reptiles that hunt them with terrifying efficiency. The Earth's skies and seas during the Jurassic are every bit as dynamic and dramatic as the landscapes on land. The earliest pterosaurs appeared in the late Triassic, but it is in the Jurassic that they come into their own. By this time, they have already mastered the skies, evolving a wide array of body shapes and sizes that allow them to exploit every aerial niche available. One of the most iconic early Jurassic pterosaurs is Dimorphodon, a creature with a broad head, large eyes, and teeth suited for catching fish and small animals. Its wings, supported by an elongated fourth finger, stretched wide as it glided along the coastlines of what is now Europe. Fossils suggest that Dimorphodon was agile, but not built for long-distance soaring. It likely darted between trees and cliffs, swooping down to snatch prey before retreating to safety. Other Jurassic pterosaurs, like Rhamphorhynchus, perfected different strategies. With long tails tipped by diamond-shaped veins, these creatures were elegant flyers. Rhamphorhynchus lived near lagoons and shallow seas, its narrow teeth perfectly suited to grasp slippery fish. Some fossils preserve stomach contents, giving us a glimpse into their diet. Remarkably, fossils of Rhamphorhynchus also show evidence of wing membranes, providing clues about the texture and shape of their wings, and even the presence of pycnofibers, hair-like structures that may have helped regulate body temperature. As time progressed, pterosaurs diversified into a remarkable range of forms. Some grew to impressive wingspans, capable of soaring for long distances over seas and coastlines. Others remained small and agile, darting through forests and wetlands. Their dominance of the skies was not absolute. Small feathered dinosaurs were beginning to experiment with gliding and primitive flight. But for the Jurassic, pterosaurs remained the undisputed masters of the air. While pterosaurs ruled the skies, the oceans were kingdoms of their own. During the Jurassic, marine reptiles reached new levels of diversity and specialization. unlike the dinosaurs, these reptiles did not descend from the same lineage. They were a collection of groups that had each adapted separately to life in the water, filling different roles in marine ecosystems. Ichthyosaurs were among the most successful. Sleek, fast, and shaped much like modern dolphins, they had evolved into efficient marine predators. With long snouts filled with conical teeth, ichthyosaurs hunted fish and squid in the open seas. Fossils of species like Stenopterygius and Ophthalmosaurus reveal adaptations for deep diving, including enormous eyes that allowed them to see in low light. Some ichthyosaurs were so specialized for life in the water that they could give birth to live young, a remarkable adaptation for reptiles. Fossilized skeletons of mothers with embryos still inside provide direct evidence of this evolutionary leap. Alongside them swam the plesiosaurs, a group of marine reptiles with a very different design, with long, flexible necks and small heads. Plesiosaurs such as Cryptoclydus and Plesiosaurus were elegant hunters. Their 4 powerful flippers propelled them through the water like underwater birds, using a unique form of locomotion that has no exact parallel in the modern world. Fossilized stomach contents suggest they fed on fish, squid, and other small marine animals, seizing prey with quick strikes of their tooth-filled jaws. In contrast, the pliosaurs, close relatives of plesiosaurs, took a different path. With massive skulls and shorter necks, pliosaurs were apex predators of the Jurassic seas. Creatures like Liopleurodon dominated coastal waters, their powerful jaws capable of crushing large prey. At lengths estimated up to 10 meters or more, pliosaurs rivaled the land-dwelling theropods as some of the most fearsome predators of the age. Ammonites, with their spiral shells, were among the most common animals in these oceans. They floated in huge numbers, feeding on plankton and serving as food for a wide variety of predators. Their shells, preserved in fossil beds across the globe, are today among the most useful tools for geologists. Because ammonites evolved quickly and were widespread, their fossils help scientists precisely date the rocks in which they're found. The interaction between land and sea created some of the richest environments of the Jurassic. Shallow lagoons, tidal flats, and estuaries teemed with life. Pterosaurs circled overhead, plunging into the water to catch fish, while marine reptiles lurked below. In what is now Germany, the Solnhofen limestone preserves an extraordinary glimpse into such an environment. Fine-grained sediments captured not only marine creatures like fish and ammonites, but also pterosaurs, insects, and even the earliest known bird, Archaeopteryx, which lived near these coastal lagoons. The exceptional preservation of these fossils provides an almost photographic record of life in the late Jurassic, showing the delicate structures of wings, feathers, and membranes in astonishing detail. The Jurassic skies and seas were not isolated from the land. They were part of a vast, interconnected web of ecosystems. Herbivorous dinosaurs along coasts provided carrion for scavengers. Pterosaurs fed not only on fish, but also on small terrestrial animals, insects, and even the eggs of dinosaurs. Marine reptiles, in turn, fed on pterosaurs that ventured too close to the water's surface. Every niche was exploited, and every environment was filled with life. The global climate during the Jurassic, warm and humid, helped sustain these rich ecosystems. Higher sea levels created widespread shallow seas, which acted as nurseries for marine life. Continental drift was slowly rearranging the world, creating new coastlines and island chains that offered habitats for both pterosaurs and marine reptiles. By the close of the Jurassic, both pterosaurs and marine reptiles had achieved an extraordinary level of diversity. Some pterosaurs had wingspans rivaling small planes, soaring high over seas, while others were no larger than modern seagulls. In the oceans, ichthyosaurs, plesiosaurs, and pliosaurs occupied every available niche, from fast pursuit predators to slow ambush hunters. This expansion into skies and seas ensured that during the Jurassic, vertebrates truly dominated every realm of the planet. On land, dinosaurs towered over forests and plains. In the skies, pterosaurs claimed the air, and in the seas, marine reptiles hunted with unmatched efficiency. The stage was now set for the later Jurassic, when dinosaurs on land would reach new heights of size and complexity. But even as the great herds of sauropods expanded, the skies and oceans remained crucial parts of the Mesozoic story. For this was a time when life was not only diverse, it was spectacularly interconnected, with ecosystems spanning every corner of the globe. The Jurassic period was a time of abundance. The earth was warm, humid, and filled with vast forests that spread across much of the globe. Rising sea levels created inland seas, coastal wetlands, and lush floodplains. Across these landscapes, dinosaurs thrived. From the largest creatures ever to walk the land to swift predators and armored plant eaters, the Jurassic was an era where the balance between predator and prey reached new levels of complexity. It was here, on these landscapes of towering conifers and fern-rich ground cover, that dinosaurs became not just successful survivors, but true ecosystem architects, shaping every aspect of the environment around them. The most iconic image of the Jurassic is that of the giant sauropods. These long-necked, long-tailed herbivores dominated the land in a way no group of animals has before or since. Herds of Brachiosaurus, Diplodocus, Apatosaurus, and their relatives moved across floodplains, consuming massive amounts of vegetation every day. Take Brachiosaurus, for example. With forelimbs longer than its hind limbs, this dinosaur's body tilted upward, giving it a giraffe-like posture. Its head could reach trees nearly 13 meters, 43 feet high, allowing it to browse vegetation far out of reach for most other herbivores. A single adult Brachiosaurus may have weighed over 40 tons, supported by 4 pillar-like legs and an immense lung system that helped oxygen flow efficiently through its enormous body. Meanwhile, Diplodocus, with its astonishingly long neck and whip-like tail, grazed differently. Its low slung body allowed it to sweep across wide areas of vegetation near the ground, while its tail, which may have functioned as a whip, could have served as both a defense mechanism and a communication tool within herds. These giants did not move alone. Fossil evidence suggests they traveled in herds, sometimes spanning great distances to follow food and water sources. Their presence transformed entire landscapes, stripping forests bare, dispersing seeds, and trampling paths through vegetation. In this way, sauropods acted much like modern elephants, shaping ecosystems simply by existing. Where there are giants, there are hunters. The Jurassic was also the age of apex predators, chief among them Allosaurus. This theropod, reaching up to 9 meters, 30 feet, in length, was the dominant carnivore of the late Jurassic landscapes of North America. Allosaurus was not as massive as later predators like Tyrannosaurus rex, but it was agile and powerful. Its jaws were lined with serrated teeth, designed not for crushing bone, but for slicing through flesh. Paleontologists suggest that Allosaurus may have used a bite and tear strategy, slashing at prey with its jaws and powerful arms, then waiting for blood loss and weakness to bring the victim down. Evidence from fossilized bone beds suggests that Allosaurus may have hunted in groups, particularly when targeting giant sauropods. Coordinated hunting would have allowed them to bring down prey many times their own size. But these hunts were risky. Fossils show injuries on both predator and prey, telling the story of a brutal evolutionary arms race. Other predators, like Ceratosaurus and Torvosaurus, shared the landscape with Allosaurus. Ceratosaurus, with its distinctive nasal horn, may have specialized in different prey, such as smaller herbivores or aquatic animals along rivers. Torvosaurus, large and more heavily built, was another apex hunter that competed with Allosaurus in the same ecosystems. Together, these predators ensured that no environment was safe from danger, maintaining the balance between herbivore populations and the resources they consumed. Not all dinosaurs relied on size or speed to survive. Some evolved armor. The Jurassic saw the rise of stegosaurs, plant eaters equipped with plates and spikes that offered both defense and display. One of the best-known stegosaurs is Stegosaurus, with its double row of large, upright plates running down its back and the fearsome spikes of its tail, known as the thagomizer. Though the exact purpose of the plates remains debated, many paleontologists believe they were used for display, perhaps to attract mates or intimidate rivals, while the tail spikes were undoubtedly weapons, capable of injuring or even killing predators like Allosaurus. Despite their formidable defenses, stegosaurs were relatively slow-moving herbivores, feeding primarily on low-growing plants. Fossil evidence suggests they lived in groups, using safety in numbers and their collective defenses to reduce the risk of predation. Their presence added another layer of diversity to the Jurassic ecosystems, showing how herbivores evolved not only in size, but also in strategy. The Jurassic wasn't only about giants. Smaller herbivores also thrived, filling important ecological roles. Dinosaurs like Camptosaurus, a medium-sized herbivore with a flexible beak for cropping vegetation, roamed in herds across the plains. Agile and fast, Camptosaurus relied on speed and group living rather than armor or size to avoid predators. Other ornithopods, two-legged plant eaters, added to the diversity. These dinosaurs were the evolutionary precursors of the great hadrosaurs of the Cretaceous. But in the Jurassic, they were still relatively small and nimble, feeding on a wide variety of plants and spreading across continents. Their role as prey was vital. They sustained the mid-sized predators of the Jurassic and helped maintain balance in ecosystems dominated by massive sauropods and their hunters. To imagine Jurassic landscapes is to envision vast ecological diversity. Forests of towering conifers and cycads created shaded environments where stegosaurs and smaller ornithopods fed on undergrowth. River valleys and floodplains supported herds of sauropods, moving in long lines to graze and drink. Coastal plains were home to diverse communities, linking land animals to the marine life that thrived offshore. In North America, what is now the Morrison Formation preserves this environment in exquisite detail. Here, layers of rock contain the remains of sauropods like Apatosaurus, Diplodocus, and Brachiosaurus. Predators like Allosaurus and Ceratosaurus, and a host of smaller dinosaurs. The Morrison Formation paints a picture of a world alive with interactions, where every niche was filled. Dinosaurs were the giants of the Jurassic, but they were not alone. Insects buzzed through forests, pollinating plants and feeding on leaves. Mammals, though small, continued to survive in the shadows. These early mammals were nocturnal insect eaters, resembling shrews and opossums. Though insignificant compared to dinosaurs, they carried the genetic legacy that would one day dominate the earth after the dinosaurs' fall. Amphibians, crocodile relatives, and turtles also thrived in Jurassic rivers and wetlands. Crocodiliforms, in particular, diversified, filling niches from fish eaters to terrestrial hunters. These smaller reptiles competed with dinosaurs at the edges of ecosystems, though none could match their sheer dominance. The Jurassic world was defined by its predator-to-prey balance. Every advance by predators spurred adaptations in herbivores, and vice versa. Sauropods grew larger, making it harder for predators to attack them. Predators evolved sharper teeth and stronger jaws. Armored dinosaurs developed spikes and plates, forcing predators to adapt their hunting strategies. This dynamic tension fueled evolutionary innovation, creating an ever-changing landscape of survival. The diversity of life in the Jurassic reflects not only opportunity, but also the constant pressure of competition. By the end of the Jurassic, dinosaurs had achieved a level of dominance unmatched in Earth's history. They towered over landscapes, filled the skies with their cousins the pterosaurs, and lived alongside oceans ruled by marine reptiles. The Jurassic was the golden age of the giants. It was a world where land shook beneath the weight of herds, where predators measured themselves against creatures many times their size, and where the balance of ecosystems was defined by the interplay of enormous, powerful animals. This golden age would eventually give way to new challenges in the Cretaceous, a time of shifting continents, flowering plants, and new waves of dinosaur diversity. But the Jurassic stands as the era where dinosaurs truly became the rulers of the land, shaping the very fabric of life on Earth. The transition from the Jurassic into the early Cretaceous was not abrupt but gradual, a continuation of the Earth's deep rhythms of climate, geology, and life. Yet, by 145 million years ago, subtle changes began to reshape the face of the planet. Continents drifted further apart, climates shifted, and new ecosystems emerged. Dinosaurs, already dominant, adapted in remarkable ways, expanding into niches that would sustain them through the next 80 million years. This was the stage for innovation. It was the time when Earth's landscapes took on forms more familiar to us today, when flowering plants first began to spread, and when dinosaurs evolved into even more diverse and specialized forms. The early Cretaceous was an era of transition, but also one of vitality, where old worlds gave way to new possibilities. At the dawn of the Cretaceous, the supercontinent of Pangaea was long gone, broken into fragments that continued to drift across the globe. The Atlantic Ocean widened as North America and Europe pulled away from Africa. South America began to separate from Africa as well, creating the early outlines of the continents we know today. This tectonic activity reshaped coastlines, created new inland seas, and altered climates. Regions that had once been part of vast continental interiors became coastal environments, with warm, shallow seas teeming with life. Other regions grew drier as mountains rose and climates shifted. The breakup of continents also meant the isolation of ecosystems. Where once dinosaurs could travel freely across supercontinents, now they became increasingly separated by oceans and seas. This isolation encouraged evolutionary branching, leading to new forms of dinosaurs uniquely adapted to their local environments. The climate of the early Cretaceous remained generally warm, with no polar ice caps. Yet compared to the Jurassic, there were more regional variations. Some areas experienced arid conditions, with deserts expanding across parts of Africa and Asia. Other regions were lush and wet, particularly along coastlines and in equatorial zones. The greenhouse conditions that had begun in earlier periods continued, with high levels of carbon dioxide in the atmosphere. These conditions supported dense vegetation and promoted rapid plant growth, which in turn sustained large populations of herbivores. Seasonal changes, however, became more pronounced in higher latitudes, with evidence of wet and dry seasons shaping ecosystems. Perhaps the most significant ecological change of the early Cretaceous was the rise of angiosperms, flowering plants. While conifers, cycads, and ferns still dominated, small flowering plants began to appear in river valleys, floodplains, and disturbed environments. These early angiosperms were not yet the forests of flowers and fruit we know today, but their arrival marked a revolution. Flowers attracted pollinating insects, creating new ecological relationships. Angiosperms grew quickly and spread into new areas, offering a more varied and nutritious food source for herbivores. Though modest at first, this botanical shift would accelerate through the Cretaceous, changing the diets and behaviors of dinosaurs and transforming the Earth's landscapes forever. The herbivorous dinosaurs of this era were as diverse as the plants they fed upon. Iguanodonts, a group of large, beaked plant eaters, became widespread. They were versatile feeders, able to graze on low vegetation or rear up on their hind legs to browse higher branches. One of the best known examples is Iguanodon, whose thumb spikes could have been used both for defense and for breaking open tough plants. Alongside them were ankylosaurs, heavily armored dinosaurs, whose bodies were covered in bony plates and spikes. These low-slung herbivores moved through forests like living tanks, their heavy tails sometimes tipped with clubs capable of breaking the bones of attacking predators. Sauropods, too, continued to thrive in many parts of the world. Though not as globally dominant as in the Jurassic, groups such as the brachiosaurids and titanosaurs expanded into new regions, particularly in South America and Africa. Titanosaurs would eventually grow to be the largest land animals in history, and their rise began in these early Cretaceous ecosystems. The herbivores of the early Cretaceous were not only diverse in form, but also in behavior. Fossil trackways suggest herding and migration, with large groups of dinosaurs moving across landscapes in search of food and water. These behaviors help sustain populations and shape the ecosystems around them. With new herbivores came new predators. The early Cretaceous saw the rise of carcharodontosaurs, massive theropods with blade-like teeth designed for slicing through flesh. These predators, some exceeding 12 meters in length, became apex hunters across much of Gondwana. Other predators included the spinosaurids, a unique group of theropods with elongated jaws and conical teeth adapted for catching fish. Spinosaurids like baryonyx show that these dinosaurs spent much of their time near rivers and lakes, blending the roles of terrestrial and aquatic predators. Their crocodile-like skulls and claws made them formidable hunters of both fish and smaller dinosaurs. In Asia, smaller but agile predators such as the early dromaeosaurs, the so-called raptors, emerged. These feathered predators, with sickle-shaped claws on their hind feet, hunted in packs or used ambush tactics. Though small compared to the giant carcharodontosaurs and spinosaurs, they represented a new evolutionary path that would eventually lead to birds. The diversity of predators in the early Cretaceous reflected the complexity of its ecosystems. From giant land hunters to fish-eating specialists, carnivores filled every niche. The landscapes of the early Cretaceous were mosaics of old and new. In some places, sauropods still dominated floodplains, while in others, iguanodonts and ankylosaurs shaped the plant communities. Forests of conifers and cycads still loomed, but patches of flowering plants began to spread, changing the diets of herbivores and the insects that fed upon them. Coastal environments linked land and sea. Dinosaurs foraged along shorelines, while pterosaurs soared above, and marine reptiles hunted below. River valleys provided rich environments for both plants and animals, creating centers of biodiversity. This was not a static world, but one of constant change. The breakup of continents, shifting climates, and new evolutionary innovations kept ecosystems dynamic and diverse. While dinosaurs ruled the land, mammals continued to evolve quietly in the background. By the early Cretaceous, mammals were more diverse than in the Jurassic, including insectivores, small omnivores, and even early forms adapted for gliding or burrowing. Though small and overshadowed by dinosaurs, mammals occupied ecological niches that dinosaurs did not. Their nocturnal habits, keen senses, and diverse diets allowed them to thrive in environments where survival depended on adaptability. These small creatures carried within them the evolutionary potential that would one day reshape the Earth after the fall of the dinosaurs. The early Cretaceous was a time of innovation. Dinosaurs diversified into new forms, predators adapted to new hunting strategies, and plants transformed ecosystems with the first flowering species. Insects responded to these changes, and mammals quietly expanded into new roles. This was not yet the peak of dinosaur diversity. That would come later, in the late Cretaceous. But it was a critical chapter in their history. The foundations laid in the early Cretaceous would shape the world for tens of millions of years to come. As continents drifted and climates shifted, dinosaurs showed their remarkable ability to adapt, ensuring their place as rulers of the earth for yet another era. The early Cretaceous set the stage, but it was in the later chapters of the period that dinosaurs truly blossomed into their greatest diversity. From 100 to 80 million years ago, ecosystems across the globe teemed with new forms of life. The planet itself had shifted dramatically since the Jurassic. Continents were far apart, climates were more varied, and plants were undergoing a revolution with the rapid rise of flowering species. It was into this transformed world that dinosaurs adapted with dazzling variety. The Cretaceous was not just a continuation of their reign. It was the high point when their shapes, behaviors, and ecosystems were at their most complex and magnificent. Among the most extraordinary dinosaurs of the mid-Cretaceous were the titanosaurs, the last great lineage of sauropods. While many of their Jurassic relatives had disappeared, titanosaurs spread across nearly every continent, filling roles once held by their long-necked ancestors. Titanosaurs were diverse. Some were relatively small, only the size of elephants, while others grew into the largest land animals that ever lived. Giants such as Argentinosaurus in South America and Patagodon stretched up to 30 meters in length and weighed over 70 tons. These enormous creatures moved slowly across floodplains and forests, stripping entire groves of vegetation to sustain their bulk. Despite their size, titanosaurs were surprisingly adaptable. Fossils show they lived in deserts, forests, and coastal plains. Their widespread distribution hints at their ability to thrive in varied climates, from arid regions of Gondwana to wetter environments in Laurasia. Their success underscores the resilience of sauropods, even as the world shifted around them. As titanosaurs ruled the southern continents, the northern lands saw the rise of a very different group, the ceratopsians. Evolving from small, beaked ancestors in Asia, ceratopsians expanded into a wide array of forms by the mid to late Cretaceous. The most iconic among them were the great horned dinosaurs like Triceratops, but their story began earlier with smaller relatives such as Protoceratops. Over time, ceratopsians grew larger and developed elaborate skull frills and horns. These structures may have served multiple purposes: defense against predators, display for attracting mates, or recognition among members of their species. Ceratopsians were highly successful herbivores, adapted to grazing on tough, fibrous plants, including the newly spreading flowering species. Their strong jaws and shearing teeth made them efficient feeders, capable of processing large amounts of vegetation. In herds, ceratopsians would have been an imposing sight. Walls of horned and frilled dinosaurs moving across the plains, shaping ecosystems with their grazing and defending themselves against giant predators. If ceratopsians represented strength and defense, the hadrosaurs, or duck-billed dinosaurs, symbolized adaptability. Emerging during the mid-Cretaceous, hadrosaurs became some of the most widespread and successful herbivores of their time. Their defining feature was their broad, duck-like bills, suited for cropping plants, and their intricate dental batteries, rows of tightly packed teeth that form grinding surfaces like giant millstones. This allowed hadrosaurs to process a wide variety of plant material, including flowering plants, ferns, and conifers. Hadrosaurs lived in vast herds and were capable of walking on both 2 and 4 legs, giving them mobility and flexibility. Some species developed elaborate crests on their heads, such as Parasaurolophus, whose long, hollow crest may have been used to produce resonant calls. Others, like Corythosaurus, sported rounded crests that could have been visual signals. Their social behavior, adaptability, and feeding efficiency made hadrosaurs the most abundant herbivores in many ecosystems of the late Cretaceous, rivaling even the great herds of bison and antelope in today's savannas. Alongside hadrosaurs and ceratopsians, another lineage of herbivores thrived, the ankylosaurs. These heavily armored dinosaurs were covered in bony plates, spikes, and sometimes tail clubs that could swing with bone-crushing force. Two main groups existed: the nodosaurids, with spiny armor but no tail club, and the ankylosaurids, with broader armor and powerful tail weapons. Together, they formed an almost impenetrable class of dinosaurs, designed for defense against the largest predators. Ankylosaurs were low browsers, feeding on ferns and low vegetation, and their armor made them less vulnerable while foraging slowly. In many ways, they were the tanks of the Cretaceous world, slow but almost invulnerable. As herbivores diversified, predators evolved to keep pace. The mid-Cretaceous saw the continued dominance of the Carcharodontosaurs, massive carnivores rivaling Tyrannosaurus in size. These hunters, with their serrated teeth and muscular builds, stalked titanosaurs and iguanodonts across Gondwana. At the same time, Spinosaurids expanded their range. Some species grew enormous, like Spinosaurus, which became one of the largest carnivorous dinosaurs of all time. Its crocodile-like skull, conical teeth, and long arms with hooked claws marked it as a semi-aquatic hunter. Spinosaurus likely prowled rivers and lagoons, feeding on fish and small dinosaurs, blurring the line between land and water predator. Meanwhile, the smaller but highly intelligent raptors continued to evolve. Dromaeosaurs, such as Velociraptor and Deinonychus, developed sharp claws and keen senses, often hunting in packs or ambushing prey with swift agility. Their growing feathers showed their close connection to birds, signaling an evolutionary path toward flight. By the mid-Cretaceous, the link between small theropods and birds had become undeniable. Fossils from China revealed feathered dinosaurs with wings and even early attempts at powered flight. Creatures like Microraptor, with feathers on both its arms and legs, glided between trees. True birds, such as Archaeornithura, also flourished, diversifying into aquatic, arboreal, and terrestrial forms. The presence of both feathered dinosaurs and birds showed that flight had evolved multiple times in different ways, a hallmark of nature's experimentation. These early birds were not yet the dominant flyers of the skies. That role still belonged to the pterosaurs, but they were carving out niches that would expand dramatically in the future. The Cretaceous was not only a golden age for dinosaurs on land, but also for life in the seas. vast oceans teemed with giant reptiles, from the long-necked plesiosaurs to the powerful mosasaurs, which would later become apex predators of the oceans. Sharks diversified as well, with new forms adapted to the changing seas. Ammonites, with their coiled shells, were abundant, serving as both predators and prey. Coral reefs spread, hosting ecosystems as rich as those of modern tropical seas. Coastal zones, rivers, and estuaries provided habitats where dinosaurs, pterosaurs, and marine reptiles interacted. The boundaries between land and sea were blurred, with spinosaurids hunting fish, pterosaurs diving for prey, and marine reptiles venturing near the shores. While dinosaurs ruled the land and seas, smaller creatures were reshaping ecosystems in quieter but equally profound ways. Insects diversified in tandem with the rise of flowering plants. Bees, beetles, and butterflies began forming relationships with angiosperms, spreading pollen and accelerating the expansion of these plants. This co-evolution between insects and plants created feedback loops that transformed landscapes. Meadows, forests, and river valleys became increasingly dominated by flowering plants, offering more diverse food sources for herbivores and reshaping the diets of entire ecosystems. By the Middle to Late Cretaceous, the Earth was alive with more diversity than ever before. Giant titanosaurs roamed the southern continents. Herds of hadrosaurs and ceratopsians dominated the north, and predators of every shape and size pursued them. Birds and feathered dinosaurs blurred the lines between ground and sky, while insects and flowers reshaped the foundations of food webs. The Cretaceous was not a static world, but a dynamic, living planet, full of movement, sound, and interaction. From the thunder of titanosaurs to the calls of crested hadrosaurs, from the silent glide of pterosaurs to the scurry of mammals in the undergrowth. It was a time when life expressed itself in its most extravagant forms. The stage was now set for the last and perhaps most iconic chapter of the dinosaur reign, the age of Tyrannosaurus, Triceratops, and the final drama of extinction. The late Cretaceous, spanning roughly 80 to 66 million years ago, was the final and most dramatic chapter of the dinosaur reign. By this time, the Earth was a very different place from the world of the Jurassic. The continents had drifted further apart, climates showed more regional variation, and flowering plants had spread across the globe. Dinosaurs did not dwindle in these last millions of years. They flourished. The late Cretaceous hosted some of the most famous, specialized, and successful dinosaurs in Earth's history. Ecosystems brimmed with life. Enormous herbivores shaped the landscapes. Apex predators ruled with unparalleled power, and smaller dinosaurs blurred into the first true birds. It was the peak of dinosaur diversity, the golden finale of their 160 million year reign. By this time, the continents were approaching their modern outlines. North America had split from Europe. Africa was fully separated from South America, and India was drifting northward toward Asia. Vast inland seas, such as the Western Interior Seaway in North America, divided land masses and created unique ecosystems on each side. The climate was still warm, but polar regions experienced more seasonal variation, with evidence of temperate forests near the poles. With no permanent ice caps, sea levels were high, flooding coastal plains and creating shallow marine environments that teemed with life. The world was a patchwork of habitats, forests of flowering plants, open plains where herds of herbivores roamed, deserts, wetlands, and coastlines, all supporting an astonishing variety of dinosaurs. The late Cretaceous was dominated by three great herbivore lineages: hadrosaurs, ceratopsians, and ankylosaurs. Hadrosaurs had become the most successful herbivores on Earth. Their complex dental batteries allowed them to process tough plants efficiently, and their social herding behavior ensured safety in numbers. Crested species, like Parasaurolophus, used resonant calls to communicate, while others, like Edmontosaurus, spread across vast regions of North America. Ceratopsians reached their zenith with species such as Triceratops, one of the most recognizable dinosaurs of all time. With its massive horns and frilled skull, Triceratops was both a formidable grazer and a dangerous opponent for predators. Herds of ceratopsians would have transformed landscapes as they moved through in great numbers. Ankylosaurs perfected their armor. Species like Ankylosaurus carried thick plates across their backs and swung massive tail clubs capable of shattering bones. These low-browsers grazed on ferns and shrubs, their bodies almost impervious to attack. Together, these herbivores formed the backbone of late Cretaceous ecosystems, shaping plant communities and sustaining the predators that hunted them. Among predators, none looms larger in popular imagination than Tyrannosaurus rex. Appearing in the final few million years of the Cretaceous, T-Rex was the ultimate expression of theropod evolution. Growing up to 12 meters long and weighing over 8 tons, it combined raw power with intelligence and keen senses. Its massive skull, lined with teeth the size of bananas, could crush bone with one of the strongest bite forces in Earth's history. Evidence from fossils shows that T-Rex was both a hunter and a scavenger, capable of chasing prey and also tearing apart carcasses. Yet T-Rex was not alone. In Asia, predators such as Tarbosaurus and Alioramus filled similar roles. In South America, the giant Giganotosaurus and its relatives had dominated earlier, though they gave way to smaller but still formidable theropods by the late Cretaceous. Predator-prey dynamics in this era were intense. Vast herds of hadrosaurs and ceratopsians were matched by apex predators specialized for power, strategy, and endurance. Though sauropods had declined in much of the world, they still thrived in the southern continents. Titanosaurs continued to roam South America, Africa, and Asia. some reaching colossal sizes. Species like Dreadnoughtus and Saltosaurus carried on the sauropod legacy, feeding on high vegetation and reshaping ecosystems as they moved in herds. In these southern landscapes, predators adapted to target even these giants, keeping the ancient balance of herbivore and carnivore alive until the very end of the Cretaceous. The skies of the late Cretaceous were shared between two groups, the last of the pterosaurs and the rapidly diversifying birds. Pterosaurs, such as Quetzalcoatlus, were among the largest flying animals ever, with wingspans exceeding 10 meters. These giants likely soared across vast distances, preying on small animals or scavenging. Smaller pterosaurs still filled coastal and freshwater niches, hunting fish and insects. Meanwhile, birds were evolving rapidly. They developed modern features such as toothless beaks, strong flight muscles, and diverse diets. Some were aquatic divers, others were seed eaters, and still others were predators. By the end of the Cretaceous, birds had established themselves as a major component of ecosystems, setting the stage for their survival after the extinction. Though still overshadowed by dinosaurs, mammals were more diverse than ever before. Some were small insectivores, others were omnivores, capable of scavenging or hunting small prey. Fossil evidence even shows mammals preying on small dinosaurs, such as hatchlings, demonstrating their growing ecological presence. Their ability to live in burrows, operate at night, and exploit niches ignored by dinosaurs gave them resilience. They were still minor players in the grand theatre of the Cretaceous, but their quiet persistence was laying the foundation for the future. Late Cretaceous ecosystems were dynamic and interconnected. Herds of hadrosaurs and ceratopsians moved across plains, pursued by tyrannosaurs. Ankylosaurs foraged slowly in forests, protected by their armor. Titanosaurs towered in the south, stripping trees of leaves. Pterosaurs soared overhead, while birds darted through forests and wetlands. Insects pollinated flowers, spreading angiosperms into every corner of the land. Mammals skidded in the undergrowth. Rivers, lakes, and shallow seas hosted reptiles, fish, and amphibians. It was a planet alive with sound, color, and motion, the high water mark of Mesozoic life. Yet, even as dinosaurs thrived, subtle signs of change were brewing. Volcanic activity increased in some regions, releasing gases into the atmosphere. Sea levels fluctuated, altering coastlines and ecosystems. These were natural shifts, part of Earth's rhythms, but they hinted at the planet's volatility. Unbeknownst to the creatures of the late Cretaceous, their world was approaching a sudden and catastrophic end. For now, however, life was at its most vibrant, its most diverse, and its most spectacular. Dinosaurs ruled the earth, not as fading monarchs, but in full strength. Their reign unchallenged across land, sea, and sky. The late Cretaceous, a world of immense diversity and vitality, came to an abrupt and catastrophic end about 66 million years ago. Dinosaurs had dominated the planet for over 160 million years, but in a single geologic instant, most species vanished. The end Cretaceous extinction was not the result of slow, gradual change alone. It was a combination of multiple factors, culminating in a global catastrophe. The most famous of these events is the asteroid impact. Geological evidence points to a massive bolide striking near the present-day Yucatan Peninsula in Mexico, forming the Chicxulub crater. The asteroid, estimated at 10 to 15 kilometers in diameter, unleashed energy billions of times greater than any human-made explosion. It sent shockwaves through the Earth's crust, triggered earthquakes, and caused tsunamis along coastlines across the planet. The impact released enormous amounts of dust and debris into the atmosphere, blocking sunlight for months. Photosynthesis collapsed, and temperatures dropped sharply, a phenomenon known as an impact winter. Plant life withered, and herbivorous dinosaurs faced famine. With food sources gone, carnivores soon followed. Fossil evidence shows that even the most dominant species, like Tyrannosaurus rex and Triceratops, disappeared rapidly from the fossil record after the event. Simultaneously, wildfires ignited across continents. The heat of re-entering ejecta likely scorched forests, adding smoke and soot to the already darkened skies. Acid rain, triggered by sulfur compounds released from the impact, further devastated ecosystems. Within a few months, the lush, green world of the late Cretaceous became a cold, dark, and barren landscape. While the asteroid was the most immediate cause of extinction, prolonged volcanic activity played a significant role. In India, the Deccan Traps erupted, releasing massive volumes of lava over thousands of square kilometers. These eruptions persisted for hundreds of thousands of years, emitting enormous amounts of carbon dioxide and sulfur dioxide. The greenhouse gases contributed to long-term climate changes, causing warming episodes, while sulfur aerosols led to temporary cooling and acidification of oceans. The combination of asteroid impact and volcanic stress created a 1-2 punch, overwhelming ecosystems already vulnerable to environmental change. The oceans, too, suffered dramatically. Plankton populations collapsed due to reduced sunlight and shifts in ocean chemistry. Coral reefs died out, and many marine reptiles perished. Ammonites, once abundant, vanished entirely. The extinction ripple propagated through food webs, affecting fish, mollusks, and other marine organisms. Even shallow seas that had supported diverse life became inhospitable. Fossil layers from this period show massive die-offs and sudden turnovers, marking one of the most abrupt extinction events in Earth's history. Despite the catastrophic losses, not all life perished. Some groups survived, laying the foundation for the ecosystems of the Cenozoic era. Small mammals, previously overshadowed by dinosaurs, persisted. Their ability to live in burrows, feed on insects, and remain nocturnal helped them endure the harsh conditions. Birds, the direct descendants of feathered theropods, survived as well. Though their dinosaurian cousins were gone, birds diversified in the aftermath, eventually taking flight into ecological niches left empty by extinct species. Certain reptiles, amphibians, and fish also survived, demonstrating resilience in the face of cataclysm. Plants too bounced back. Angiosperms and hardy gymnosperms repopulated devastated landscapes, creating new habitats for surviving and evolving animals. Life was not extinguished entirely. It adapted, shifted, and began anew. The end Cretaceous extinction marks both an end and a beginning. It ended the reign of dinosaurs, extinguishing the giants that had shaped Earth for millions of years. Yet, it also created opportunities for mammals, birds, and new plant species to flourish. The dramatic losses reshape food webs, ecosystems, and evolutionary trajectories. Species that survived would diversify in the Paleogene, eventually giving rise to the modern fauna of Earth. The extinction event reminds us of the fragility of even the most dominant species in the face of rapid environmental upheaval. For millions of years, dinosaurs had ruled with unmatched dominance. Their legacy, however, endures in birds, in the patterns of evolution, and in the fossils that continue to tell the story of a planet once dominated by giants. The late Cretaceous was a world of extremes, towering titanosaurs, armored ankylosaurs, crested hadrosaurs, apex predators, and thriving ecosystems. Its sudden end demonstrates the interconnectedness of life and Earth's systems. The extinction reminds us that even the most dominant life forms are subject to the forces of nature. Yet from catastrophe comes renewal. Mammals, birds, and new plant communities would rise to dominate, ensuring that life on Earth continued its remarkable journey. The dinosaurs may have vanished from the land, but their reign shaped the very course of evolution, leaving a legacy that continues to captivate our imagination today. With the impact and volcanic events of the end Cretaceous behind it, Earth entered a period of profound transformation. The giants that had dominated for over 160 million years were gone. In their place, a world of new possibilities emerged, shaped by the survivors of the cataclysm and the empty ecological niches left behind. The Paleogene period, beginning immediately after the extinction, was a time of recovery, adaptation, and rapid evolution. Forests began to regrow, flowering plants spread across continents, and insects flourished alongside them. The reshaping of ecosystems allowed surviving animals to expand into roles once held by dinosaurs, setting the stage for the modern world. Mammals, long overshadowed by dinosaurs, finally began their rise. Small, nocturnal creatures had survived by staying hidden, burrowing, or exploiting niches ignored by larger animals. In the aftermath of extinction, they diversified rapidly. Herbivorous mammals began feeding on newly abundant flowering plants, while carnivorous mammals hunted insects, fish, and smaller vertebrates. Over millions of years, mammals evolved into a wide range of sizes, from tiny shrew-like species to creatures weighing hundreds of kilograms. Some developed specialized adaptations, such as high-crowned teeth for grazing or long limbs for running across open plains. The extinction of the dinosaurs opened ecological space that allowed mammals to experiment with form, function, and behavior. They would go on to dominate terrestrial ecosystems for the first time in Earth's history. Birds, descendants of feathered theropods, also flourished in the post-dinosaur world. Without large predators and competitors, they diversified into aquatic, terrestrial, and aerial niches. Many evolved into forms specialized for swimming, diving, or predation, while others occupied forests and grasslands as seed eaters, insectivores, or scavengers. Reptiles survived as well, particularly in aquatic environments. Crocodilians, turtles, and snakes persisted and adapted to the changing climates. Some reptiles evolved new forms, filling niches in forests and wetlands that were once dominated by dinosaurs. Plants rebounded quickly after the extinction. Flowering plants, angiosperms, expanded dramatically, creating diverse forests, wetlands, and grasslands. Ferns and other hardy plants recolonized disturbed soils, stabilizing ecosystems and providing food for herbivorous mammals and birds. The co-evolution between plants and insects accelerated. Pollinators spread flowers across the continents, increasing plant diversity and creating complex ecological networks. Ecosystems became increasingly interdependent, with food webs rebuilding around new dominant species. The oceans too recovered. Marine reptiles like mosasaurs vanished, but sharks, rays, bony fishes, and early marine mammals thrived. Coral reefs re-established themselves, and plankton populations rebounded, stabilizing the base of marine food chains. Seas became productive again, supporting complex ecosystems of fish, mollusks, and early whales. This period of marine recovery mirrored the terrestrial rebound, showing the resilience of life in the face of catastrophic disruption. By the middle of the Paleogene, Earth had transformed into a new world. Forests dominated the land. Flowering plants covered plains and valleys, and mammals of all sizes roamed freely. Birds, reptiles, and insects diversified to fill available niches. The planet was no longer the world of giants. Dinosaurs, for all their power, had left behind only footprints, fossils, and birds. In their absence, evolution experimented rapidly, producing forms that would define the Cenozoic era: grazing mammals, predatory carnivores, flying birds, and aquatic mammals. This post-dinosaur world was dynamic and fertile, a testament to the resilience and adaptability of life. Ecosystems became more complex, interactions more intricate, and the stage was set for the rise of modern biodiversity. The extinction of dinosaurs was both an end and a beginning. It ended a reign that had lasted millions of years, marked by massive giants, apex predators, and spectacular diversity. Yet it also initiated a new chapter, giving life the opportunity to reinvent itself. The rise of mammals, the spread of birds, the recovery of plants, and the renewal of marine ecosystems demonstrate the extraordinary adaptability of life. Earth had been reshaped, but it continued, thriving in new forms and directions. The story of the dinosaurs, from their emergence to their extinction, reminds us of the transient nature of dominance and the enduring resilience of life. Even in the aftermath of catastrophe, life finds a way, evolving, adapting, and flourishing once more.